In question 6, we are given a bag which is in the shape of a cuboid, which has a width of 12 centimeters, a length of 36 centimeters, and a height of 9 centimeters. And in part A, we're asked to calculate the area of cloth needed to make Haruka's bag. Now, we're told that the bag is made from 5 rectangular pieces of cloth. So let's start with the base. So this is the base of the bag, and we can see that that is going to be 12 by 36. Now we can also see that we've got the front panel here, which is going to be 9 times 36. But hopefully you can see that we've also got the same area on this panel at the back here. So we've actually got 2 of those, and then similarly on the side panel, we've got this side panel here, which is going to be 9 times 12, and obviously we've got the same thing over here. This side panel here is also going to be 9 times 12, so we've got 2 of those. If we add those all together, we are going to get an answer of 1,296 centimeters squared, or 1,300 if we are going to 3 significant figures. For part B, we're asked to calculate the volume. Now, the volume is just going to be the area of the base, which is 36 times 12, multiplied by the height, which we've said is 9. And if we do that, we get an answer of 3,888, or 3,890 centimeters cubed to 3 sig fig. In part C, we are told that Nanako decides to make her own eco-friendly bag, also in the shape of a cuboid, such that the surface area is minimized. We know that the width of the bag is X centimeters, and the length is 3 times its width, so that's going to be 3x, and its height is y centimeters. And we're also told that the volume is equal to 3,888 centimeters cubed. And we're asked to write down, which means it should be fairly straightforward, and simplify the equation in x and y for the volume of Nanako's bag. Now, we said in the previous question that the volume is the area of the base, which is here going to be 3x times x, multiplied by the height, which is y. So we know the expression for the volume is going to be 3x squared y, and we know that that is going to be equal to 3,888 centimeters cubed. So if we divide both sides by 3, our expression is going to be x squared y equals 1,296. For part D, we're asked to write down and simplify an expression in x and y for the area of the cloth A used to make Nanako's bag. So again, we can adopt the same process here. Look at the individual panels. We can start by working out the area of the base, which is going to be 3x times x. We can then look at the front face, which is going to be this area here, which is going to be 3x times y. But we're also going to have the same on the back here, on the reverse, which is also going to be the same area. So we've got 2 of those. And then we can look at the side panels. Say here, the area of this is going to be x times y. And again, on the other side, over here, this panel here is going to have the same area. So we can multiply that by 2. So if we add that all together, we are going to have 3x times x, so 3x squared, plus 3x times y times 2 is going to be 6xy, and then x times y times 2 is going to be 2xy. So that is going to give us 3x squared plus 8xy for the area of the bag. For part E, we need to draw on our previous answers. So we found in part C that x squared y was equal to 1,296. And in part D, we found the surface area is equal to 3x squared plus 8xy. And we need to somehow use that information to show that the surface area A can be expressed 3x squared plus 10,368 over x. So if we look at what we've got already, we're trying to find an expression for the area. So let's start by looking at what we've got. We know our current expression is A equals 3x squared plus 8xy. Now we can see that the answer we're trying to get to is an expression given in terms of x. So somehow we want to express this y in terms of x, and we can see we've actually got an expression here which enables us to do that. So we can rearrange this expression by saying that y is equal to 1,296 divided by x squared, and then we can actually substitute that in here. So we can rewrite this as 3x squared plus 8x multiplied by 1,296 over x squared. And hopefully we can see that this x is going to cancel out with this one. So we're going to be left with 3x squared plus just the 8 times 1,296, which is going to give us 10,368 over x. So we've found an expression for the area in terms of x, and then in part F we are asked to differentiate this to find the gradient function. So before we differentiate this, we want to actually express it using rational exponents. So we're not differentiating in the first step. So the 3x squared, we're going to leave that as it is, but we're going to rearrange the second term using rational exponents. So if it's divided by x, that's the same as multiplying by x to the minus 1. So we can write this as 10,368x minus 1. Now we've got rational exponents, we can differentiate that. So dA by dx, we can differentiate each of these terms. 2 times 3 is 6x to the power 2 minus 1, which is just going to be 1, so that's 6x. And then again, if we've got 10,368 multiplied by minus 1, the exponent, so that's been negative 10,368. And this is the one that people often make a mistake with. If we've got x to the power negative 1 and we subtract 1, we're going to end up with negative 2. So we can leave our final answer like that, or if we want to tidy it up, we can just rewrite it as 6x minus 10,368 divided by x squared. Both of those are correct. In part G, we're asked to use the gradient function, dA by dx, to show that the width of Nanako's bag must be 12 centimetres. So to do this, we need to think back to what her initial objective was, which is to minimise the surface area of the material used. So if we're looking at minimising it, we want to identify the minimum point, and at a minimum point, the gradient dA by dx will be equal to 0. So we can set our expression for the surface area equal to 0 and rearrange it. So therefore 6x is going to be 10,368 over x squared. Multiply both sides by x squared, you're going to have 6x cubed equals 10,368 divided through by 6, and you're left with x cubed is equal to 1,728. So therefore x is going to be the cubed root of 1,728, which equals 12 centimetres. Finally, in part H, we're told that the cloth used to make her bag costs 4 yen per centimetres squared, and we're asked to therefore find the cost of the cloth used to make her bag. So in order to do that, we need to know the area of the bag. So going back to part E, when we found an expression for the surface area here is equal to 3x squared plus 10,368 over x. We now know what x is because in the previous question we found that x was equal to 12. So what we're going to do now is substitute that in. So 3 times 12 squared plus 10,368 over 12 is going to give us 1,296 centimetres squared. So it's 4 yen per centimetre squared. So you need to multiply that by 4 to get the final answer, which is going to be 5,100 5,184 or 5,180 yen, correct to 3 sig fig.